Hi, welcome to Geometric Sequences. We're going to start in Key Skill 1 by looking at what is a geometric sequence and some terminology around geometric sequences. So let's get started. This is a geometric sequence because in order to get the next term, so these are all terms in the sequence. This is the first term, the second term, the third term, and the fourth term. In order to generate the next term, each time we're going to do the same thing, and that's times by 2. Times by 2. Each time we're multiplying by 2. If you need to add or subtract a number, then that's going to be an arithmetic sequence. So we've been asked in this question to state A, R, and N of the geometric sequence. So A is always the first term in the sequence, so this is always A. So here we have A is equal to 5. R is what you multiply each time to get from one term to the next. So R is 2 because we multiply by 2. And in this case, there are 1, 2, 3, 4 terms in the sequence, so N will be 4. If you see a ... that means your sequence goes on indefinitely. In question 2, we've been asked again to state A, R, and N. So if we remember, A is the very first term in the sequence, so this one is A. So A is 5. R is what we multiply each time to get to the next sequence. So what do we need to multiply 5 by to get to 15? Well, by 3. And again, 15 times by 3 will be 45 because 10 times by 3 is 30 and 5 times by 3 is 15. If I add together 30 and 15, I'll get 45. Each term is times by 3. So R is 3. And N, there are 1, 2, 3, 4 terms in the sequence. In question 3, we've been asked to fill in the blank in a geometric sequence. Now, because we've been told specifically that it's geometric, I'll add in sequence here, we know that if I multiply 4 by 5 to get to 20, then I'll multiply 20 by 5 to get to the next number, and this number, the missing number, by 5 to get to 500. The missing term is the third term, so that will be N is equal to 3. That will be important later on. First term, N is 1. Second term, N is 2. Third term, N is 3. And fourth term, N is 4. So if I want to go from the second term to the third term, I need to multiply by 5 because 4 times 5 is 20. So I must also multiply 20 by 5 to get to the next term. 20 by 5 is 100. You can think 2 by 5 is 10 and add an extra 0. And we can check if that's correct because we should also multiply the third term by 5 to get to the fourth term. 100 times 5 will be 500. So 100 is the correct answer here, the missing third term. State A, R, and N of the geometric sequence. So here we have A is the first term, A is 8. R is what we need to multiply each term to get to the next one. Now you'll notice here that we've got minuses, so we must have multiplied positive number here by a minus number each time to get to the next term. So 8 times by what will be 16? It will be 2. But we'll have 8 times minus 2 because we need to change from positive to negative. Similarly, minus 16 times by minus 2, that double minus will create plus 32. So if your sequence is alternating between positive and minus, you know that you have got a negative R value. And N, 1, 2, 3, 4 again. State A, R, and N of the geometric sequence. Now we can see that we've got a sequence that's getting smaller each time. That means that our R is a fraction. So we'll start by writing down the A, which is clearly 5. So 5 times what will give you 5 over 3? If you are not sure, this is a good trick. You take the second term and you divide it by the third term. So 5/3, if you remember, to divide by 5/1, it's the same as timesing by 1/5. You invert your fraction. So here I can say that would be 5/15, which will cancel down to be 1/3. So my r will be 1/3. This trick will work anywhere. For example, if I want to find r here, I can do 20 divided by 4. Or 100 divided by 20. You take the term in front and you divide it by the term directly behind it, and that will always give you r. 500 again divided by 100 is 5. It's useful in the sequences where it's not as easy to recognize what the r is. So you take the 1 in front and you divide it by the 1 behind. Similarly, you could have taken the third one and divided it by the 1 that's behind the third one. That's the second one. So that would have been 5/9 divided by 5/3. Remember, with fractions, we want to flip the second fraction, so times 3/5. I always teach my students to cancel down their fractions before they multiply. So for example, here I would cancel down the 2 5s for 1 each. And in fact, we can cancel down here 3 and 9 because these are both in the 3 times table. So I would have 1 there and 3. What do I end up with? 1 times 1 is 1. 3 times 1 is 3. So r is 1/3. And the n, 1, 2, 3, 4, 5. There are 5 terms in this sequence. Here n would be 1, n would be 2, 3, 4, and 5. So that's the end of key skill 1. You should now know what is a geometric sequence. That is a sequence that to get the next term, you always multiply the previous term by a number, and that number is r. You should also know what are a, that's the first term, and what is r. That's what we're multiplying each time by to get to the next term. In the next key skill, we'll be looking how to find the nth term, how to create a formula for all of these sequences, and we'll be having a little dive into where you can find these formulas in the formula booklet. I hope that was useful. Don't forget now to complete your quiz skills. I'll see you in key skill 2. Bye for now.